Today we're covering synthetic division and synthetic substitution. It's related. Obviously, they both have synthetic in their name. And this is kind of fun. This lesson you'll appreciate because we're going to continue the idea of dividing polynomials. And we did long division, and it was just tedious. It reminded us of elementary school. We probably didn't like it in elementary school, and then we have to do it again with polynomials in high school. So, but you're gonna like synthetic division, and also too, it's one of those things when Common Core standards came out. It literally said in the standards, do not teach synthetic division because it's magical. And I'm like, wait, it's not magical. Right? It actually it's mathematically sound. And so that then left me to make sure that I showed you why it wasn't magical. Got it? And so I'm going to do that today. So I have example 1 and example 2. One I'm going to do with long division, and the other I'm going to do with synthetic. And the whole purpose is to show you how it is so not magical. So with that, let's take a look here at example 1. And let's review how to do this with long division. So I'm going to come here. I think I'm going to do it in black. Here we go. And we're going to take x squared plus 3x plus 5. Now, of course, I looked to see if there were any missing terms, and there aren't any, so that's why I don't have any placeholders. And we're going to divide that by x plus 1. Again, it has no missing terms, so I don't have to worry about placeholders. Okay, and I'm going to start the process, right? What do you multiply x by to get x squared? Good, it's just x. Okay, fine, x. And I'm going to distribute that through. X times x is x squared. X times 1 is 1x. Then I'm going to draw my line and change all signs. Add going down, right? The x squareds cancel out. 3x minus 1x is 2x. Okay, and if you remember correctly, we bring down one term plus 5. And we're going to repeat the process again. We're going to ask, what do we multiply the x by to get 2x? Okay, it's 2. Is that a positive 2 or a negative 2? So I'm going to write plus 2 here, and I am going to distribute it through. I'm going to distribute it through. I'm just not going to draw the arrows. I'll draw them with my pointer. So 2 times x, that's 2x. And then we're going to do the 2 times the 1, which is just 2. I'm going to draw my line and change all signs. And we're going to get 3 here. Now, if you guys remember correctly, the 3 is the remainder. Let me do a different color ink here. Let's do this. Okay, and then here at the bottom, oops, I'm going to write the answer. I'm just going to write it at the very bottom because that'll be good. So answer, it's the x plus 2, and then plus the remainder 3. That 3, though, still needs to be divided, right, by the x plus 1. So we put 3 over x plus 1. Okay, are we good with that? Okay. Now, let's do synthetic division. I'm going to walk through the steps. So example 2 will be your first experience with it. And let me focus over here. And I'm going to, what you do is you put a backwards L right here. It's kind of like, I'll call it the window. How's that? And what goes there, you take this, see how you have x plus 1 here? You're going to take, and you're the opposite of that number, and you're going to put it here. I'll tell you why opposite in just a second, but let's just trust the process right now. So the opposite of plus 1 would be minus 1. Are we okay with that? Okay, then what I'm going to do is I'm going to take the leading coefficients. There's no missing terms, so I don't have to worry about placeholders. So the coefficient on the x squared is 1. Then the coefficient on the x is 3. And the coefficient as the constant is just the 5. Now I'm going to write numbers underneath the 1, the 3, and the 5. So I'm going to leave space for those numbers. So I'll draw a line here. And then between the 3 and the 5, below the line, I'm going to put these double lines, and you'll see why those are important in just a second. Okay, how are we doing so far? Are we okay with how to set it up? Okay. So now what you do is the following. These are the steps. Okay, you take to start, you drop that first number below the line. Anytime you have a number that goes below the line, you have to multiply it by the window. So I'm going to take the 1 and multiply it by a negative 1, right? What's 1 times negative 1? Negative 1. And you're going to write that in this location right here. So I'll write negative 1 right there. Are we okay with that? Anytime you write something above the line, you're going to add it to the number that's above it. So 3 plus negative 1 is what? Okay, and we're going to write it in this location. It is 2. Oops, sorry. Now that's below the line. Remember, anything that's below the line gets multiplied by what's in the window. Negative 1 times 2, and we're going to write it in this location right here. What's negative 1 times 2? Good, negative 2. And remember, anything above the line, you're going to add going down. What's 5 plus negative 2? 3. Now, do you guys understand the arithmetic that we just did? Okay, you have to practice it, right, to get it down. But I think that you could get that, right? You drop the first number, and then anytime something is below the line, you multiply it by the window, and that goes in then this location. Anytime you have something in that location, you're going to add going down. Anything below the line gets multiplied by the window, and you write it one space over above the line. Then you add going down, and we're done at that point. Now we're going to do the following. So, oh, sorry, that's not what I wanted. Here we go. So I took, this was a quadratic. Do you see that? So you always subtract 1. 2 minus 1 is 1. So one thing that you probably notice right away, right? What's the 3 when you compare it with the one next to it? What's the 3 here when you compare it with this example over here? It's the remainder. Good. And so those double yellow lines will help point out that whenever number goes in that location is the remainder. Okay, and so now what we're going to do is we're going to write the result. So the 1 that is here, okay, that's going to be your leading coefficient. So it's going to be 1x, and the power that we're going to use is this one right here becomes the power. So it's the power of 1. Then I'm going to bring down the next number over as the next power down. So the 2, that's the coefficient of x to the 0. Oh, do I have to write x to the 0? Nope. But I'll do it for just the sake of our discussion here. And then the 3, right, we know is the remainder, so we'll put 3 here. What are we going to put in the bottom? What did we divide by? Good. A lot of students want to put -1 because in the synthetic division, we represented the x plus 1 as the -1. But you have to write the actual original divisor. And so you can see that the answer is the same, right? It's going to be x plus 2 plus 3 over x plus 1 when I just simplify that expression. Now, notice this. In terms of space, synthetic division only takes up 3 lines. Do you see that? It's always 3 lines, right? 1, 2, 3. It's always 3 lines. Now, it might be a little longer, right, going to the right, but it'll only take up 3 lines. But notice long division, right, just doing this simple one, took up 1, 2, 3, 4, 5, 6 lines. So it's already half the space. Isn't that cool? So what happened was the person that came up with synthetic division, they realized they're all like, there is a lot of like redundance here in this problem. Like they looked here and they went, well, these always cancel out. The minus 2x and the plus 2x, right? They always cancel out. So they're all like, why do I need to write that? So I'll write here, always. They're always the same. Okay, so if they're always the same, synthetic division is just going to be like, oh, we don't need them. Let's just leave it out. So I'll write here synthetic. I'll use the division symbol here. Leaves these out. Okay, because of this. Okay, now I told you it's my responsibility to show you how it's not magical, right? So let me just take a few minutes and show you how they relate. Obviously, the x squared plus 3x plus 5, that is represented in this line right here, isn't it? Are we okay with that? Look at this, the x plus 1, that's represented by the minus 1. I still have to define why it's minus, but we'll figure that out in a minute. Okay, now notice I'm not going to put in the x squared here because it's just redundant, right? It's always going to cancel out. So I'll come here. Notice this plus, whoops, that's not what I wanted. This plus negative, I'm sorry, that plus minus 1x, isn't that represented right here? Notice here that plus negative 2, isn't that represented here? You see that? Why didn't they write the 5 again? Because they were just bringing it down. He doesn't bring, the person that created this, he and or she, said, I don't need to keep bringing that down and writing it again. I'll just write it right underneath. Okay. Notice here, the x plus 2. right? That's represented by here, the 1 and the 2. And then you have here the 3, right? That's represented by the 3 there. So notice that the person that came up with synthetic division, they're still doing the exact same work. They're just removing all the redundant, like things that are just repetitive. Okay? Are we together? Then you might be all like, well, then why do we do long division at all? And it's because synthetic division doesn't always work. Boo, right? Because I like synthetic division. You're going to like synthetic division as you practice it. You'll be like, oh, this is so much better. But it doesn't always work. So, okay. Oh, I said I needed to find why it was changed to the opposite. Why do you guys think it's changed to the opposite? Yeah. Yeah, remember okay, so we have the opposite here. Remember, we were subtracting here, right? Draw your line and change your signs. So when we subtracted, we made sure that the subtraction went all the way through, didn't we? Okay, and so because of that, we have to reflect that here, but we're adding when we go down. So when we add, when we go down, in order for it to have the same effect, you take the opposite of the number that goes in the window. Does that make sense? So it's not magical, is it? I don't know what Common Core was thinking. Now, you can have the opinion that it doesn't need to be taught in Algebra 2, maybe pre-calc. So, but I think it's kind of a fun new way of looking at things. So, and that it's good to think about like, hey, just by restructuring how we write things, we actually save a lot of time and a lot of work. Okay, but I said synthetic division doesn't always work. So let's come down here and you will see it says synthetic division is a faster way to divide polynomials. Would you agree with that statement at this point? It totally is. The one drawback is that you can only divide by linear binomials. Okay? Linear binomials. So what does linear mean? Okay, we have right here the highest exponent is 1. Okay, what does binomial mean? It has 2 terms. Remember on last night's homework, or yesterday's notes, right? Didn't we have a problem where the divisor, right, what was in this location, was like x squared plus 2x plus 1? Didn't we have something like that in our notes yesterday and even in our homework? And so that means you couldn't use synthetic division, okay? So it can only happen when you have a linear binomial. So binomial, 2 terms. Linear means the highest power is a 1. Because this is a binomial, right? X squared minus 4. But it's not a linear binomial because the power is 2. Get the idea? Okay, let's go back. Let's continue progressing here. So we need to do synthetic division with missing terms and a remainder, don't we? So, and since we did remainder yesterday, I feel like we can do both in one problem. So let's go through this. So you must represent any missing terms in the divisor and dividend with 0. So let's look at our problem here. What's the highest power in the dividend? Isn't it 4? Okay, so just start looking and making sure every power is represented. Is there an x to the third? Oh, it's missing x to the third. So I'll just write an arrow here and I'll say missing the x to the third term. Okay, is there, you have to keep going because you can miss more than one term. Is there an x squared term? Yep. Is there an x term, x to the first? Is there an x to the 0? or a constant. Yes. So it's only missing the one term. Okay. And notice, is this a linear binomial? It sure is. And so I'm going to set up my window. Okay. And in my window, I'm going to take the opposite of this plus 3 here and write it here as negative 3. Then I'm going to take all these leading coefficients, right? So all the coefficients. So I'm going to bring the 1 down here. There's 1. Oh, we're missing the x to the third, so I'll put a 0 in for that one. And then I'm going to put in the negative 10, the negative 2, and the 4. Okay, I'm going to leave space to write underneath each one of those. I'm going to put my double lines between the last two numbers. I know my remainder is going to sit in this last location. So I'll write that here. And now I'm going to go through the steps. Now, if you leave out that missing term, it's going to mess everything up. So you want to make sure that you have that represented. I'm going to drop the 1. And once it's below the line, remember, you're going to multiply by the window. So negative 3 times the 1, and then we're going to put it here, is negative 3. I'm going to add going down. 0 and negative 3 is just negative 3. Anything below the line gets multiplied by the window. So negative 3 times negative 3, right? And then we're going to take and put the answer here. What's negative 3 times negative 3? 9. Adding going down, negative 10 plus 9 is negative 1. Now I'm going to multiply the negative 3 times the negative 1, putting the answer here. That will give me positive 3. Anything above the line you add going down, 1. Okay, now I'm going to multiply the negative 3 times the 1. We're going to write my answer here. Negative 3 times 1 is negative 3. Add going down, you get 1. So I got 1 as a remainder. Okay, and then remember here, the highest power was a 4. Remember I said you subtract 1. 4 minus 1 is 3. Now, why is it always subtract 1? Okay, and I do need to write my answer still. But notice it's always subtract 1. What's the leading term in the dividend, right? What you're dividing. Isn't it the x to the fourth? So I'll just write x to the fourth here. And then notice, what's the leading term in the divisor? Well, isn't that just x? Okay. So notice that this would be the same as x. This is x to the first. So it's x to the 4 minus 1, which then means it's x to the third, right? So notice, because the divisor has to be, remember, a linear binomial up here, right? And linear means that the highest exponent is a 1. So that means that in this location right here, right, that's always going to be a 1 here, isn't it? In synthetic division. And so that's why you always subtract 1. So let's just I'll write that quick little note here. Because the divisor is a linear binomial, okay, and I'll write the degree is 1. The depressed equation. Oh, that's new terminology. Do you know what I mean by depressed equation? Yeah, it's the simplified answer. I'll write that it's the quotient, right? The answer. Quotient. Always has a power 1 less than the dividend. So always has a power 1 less than the dividend. Okay, so now let's write out our answer. So the 1 that is in this location, we're going to bring that down. It's going to be 1, x, and then the highest power now will be a 3. Then I bring down the minus 3 next. That will give me minus 3x. Then I'm going to bring down the minus 1. So it'll be minus, oh, that's minus 3x to the second. Sorry, you have to count down with your exponents. And then I bring down that negative 1. And that'll be x to the first. Okay, and then I bring down the 1. At that point, it's just constant plus 1. I could write x to the 0, but we know that x to the 0 is just 1. And then plus, and now I'm going to have my remainder, which is going to be 3 over, and what's it going to be over? Good, the divisor, what you divided by. Yes, it is 1. Why did I write 3? Because I saw the red 3 right there. Sorry, it is 1, and it is over x plus 3. Okay, so when I write my answer, though, let's simplify that so we don't have all those 1s. So it'll be x to the third minus 3x to the second minus x plus 1 over x plus 3. Okay, how are we doing? Are we okay? Okay, we're doing good. Let's go to the back. Synthetic division with coefficient of divisor other than 1. This is when it's ugly, but I'll show you the ugly. It's not bad, but synthetic division. Are you convinced that when you have a linear binomial, it's a good way to go? Yeah? Okay. Synthetic division with coefficient of divisor other than 1. So in this case, here's my problem. It's right here. It's that 4 that's at that location. Do you see how it's the divisor other than 1? The divisor in this case is that 4. Okay? That actually makes this harder to do because synthetic division works only when the divisor's leading is 1. So let's write a little note here. So the divisor's leading coefficient must be 1. Therefore, divide everything by the divisor's leading coefficient. Okay, so we're going to divide everything by 4. Divide everything in this problem now by 4. Okay, so let me rewrite the problem one time here so that we can work with this. So it's 4x to the third minus 7x to the second minus 11x plus 6 divided by, and then it's 4x plus 5. So remember, because of the 4 that's in this location, I'm going to divide everything by that 4. So that's on both sides. So the simplified equation now is this. X to the third minus, 7/4 x to the second minus, 11/4 x plus 6/4, that reduces to 3/2 divided by, and now we have x plus 5/4. Boo, right? But now I do have a leading coefficient of 1 in my divisor. Do you guys see that? So that does mean I can do the synthetic division. So I will set up my window. I'll set it up nice and tall for the fraction. And I'm going to take the number that's in this location, that 5/4. I'm going to take the opposite of that 5/4, which is negative 5/4. And then I'm going to take the coefficients here. Do I have any missing terms in this problem? Highest power is a 3. There's a 2, a 1, and a 0. Okay, so there's no missing terms, is there? So I can write the 1, the negative 7/4, the negative 11/4, and the 3/2. Leave some space for fractions underneath there. Drop the 1. Negative 5/4 times 1 is negative 5/4. What's, now we're going to add those, right, going down. What's negative 5/4 and negative 7/4? Is that negative 12/4? Hey, what's negative 12/4, you guys? Yeah, that's just basically, I'll do this, negative 3, isn't it? Now I'm going to multiply the negative 5/4 times the negative 3. That negative 3, I'll put it over 1 when I multiply. Negative times a negative will give me a positive. 5 times 3 is 15. And then 4 times 1 is 4. Negative 11/4 plus 15/4 is 4/4, which is 1. Right, that reduces to become 1. And then we'll do the negative 5/4 times the 1. Well, that's easy. That's just negative 5/4. Uh-oh. I need a common denominator to combine those, don't I? What's the common denominator? 4, right? So when I go to rewrite this, it'll be something fourth. So 2 times 2 is 4. So multiply the top by 2, I get 6/4. So what's 6/4 plus negative 5/4? Isn't that 1/4? So I just depressed my equation, right, to get my quotient. It was a third power, now it's a second power. So I can rewrite this to be, right, I'm going to take the 1 here and the 2 here, right, and so it becomes 1x to the second. The next term is minus 3x to the first, and then it's plus 1x to the 0, plus, and then it's 1/4 divided by, And then it's, what do we divide by? Now we have to be careful here. We divided by x plus 5/4, right? Do you see that? Because we changed it to do the division. So I'm going to write that here. X plus 5/4. Now, there's a problem because we don't usually write our answer when we've modified things like the divisor. So we need to return the divisor. So I'll write here, right? We need to return this to the original divisor. Okay, so how are we going to do that? Well, we're going to do the opposite of what we did. What did we do up above? We divided everything by 4. So what are we going to do down here? Multiply by 4. Now, we only have to do the remainder. We don't have to worry about the quotient, right, the division that we just did. So I'm going to multiply this by 4, which has to be distributed through. And I'm going to multiply this by 4 also. Remember, whatever you do to the top, you do to the bottom, right? And if you see here, our answer then is going to be x squared minus 3x plus 1 plus 1/4 of 4 is 1. And then you can see here, 4 times x is 4x, and then 4 times 5/4 is 5. And we are now done. Okay, so that does make it harder, doesn't it? But it's not that much harder. The focus for the test, I want you to be able to do synthetic division, okay? So, but you should know how to do it when there is a leading coefficient here. Okay, how are we doing? Is anyone still copying this down? Okay, let's go down to direct substitution. This will wrap and synthetic substitution. This really leads into a future lesson that we're going to have on the remainder theorem, but it's okay. I think it would be good to put it now. So you guys know direct substitution, if you are asked to find f of 3, that means you're going to put 3 every time you have an x. So let me rewrite this here. So it'll be f of, right, x is equal to, I'm just leaving empty parentheses every time I have an x, right? So 3 times x squared minus 6 times x plus 9. And every time we have an x, we're going to put the 3 in. So here, right, you're going to get, I'm going to do the exponent there. So the 3 squared is 9. Now I'm going to do the multiplication. 3 times 9 is 27. 6 times 3 is 18. And then put the plus 9 here. And then when you combine those together, you're going to get f of 3 is equal to 18. Are you okay with that? So it turns out, and we'll study this in more detail, that you can actually do this with synthetic division and looking for the remainder. So watch this. It says find f of 3 given, it's the exact same problem. So this time in the window, I'm going to take, now, I'm gonna take the 3 here and I'm gonna put that in the window. Notice that this is the same here. It's not the opposite. When do you take the opposite? Well, it's when you pull it from a factor, right? So see here, we're dividing by a factor, right? X minus something. I know it's x plus in this case. so it's a factor. But notice down here, this is not a factor, it's just a number. So you put the number as you see it. So now I'm going to write the coefficients. Are there any missing terms here? Highest power is 2. Any missing terms? Nope. So I can just write the coefficients, which are 3, -6, 9. Leave some space to write numbers. Okay, and what I'm going to tell you, and we'll talk more detail, what you get for the remainder will be f of 3. So let's see what happens here. Drop the 3. So I should get 18, right? Do you see that? That should be 18 here, because I'm doing, if it's true. So 3 times 3 is 9. I can write that there. -6 times 9. I'm sorry, -6 plus 9 is 3. 3 times 3 is 9, and then 9 plus 9 is 18. Okay, so I'll just write it this way. F of 3 is equal to 18. And notice that the remainder gives you the same as if you had plugged in the value with direct substitution. Isn't that cool? Okay, let's do this one more time. Let's set this one up together, and then you can do the substitution. So here, I'm going to draw my backwards L. What's going to go in the window this time? Yeah, -2, right? It's the same. Okay, and then the numbers, are there any missing terms if the power is 3? 3, 2, 1, 0. Nope. So now I could just write those coefficients, right? 3, 8, 5, -7. Skip some, or leave some space to write our problem. Okay, and I know that I dropped the 3. Oh, sorry, you guys do this work now. I wanted you to practice doing the arithmetic. And you can check your answer with mine. I happen to got f of -2 is -9. Are there any questions? Great. That will wrap up the lesson.